Hello students, welcome back to the lecture series on discrete mathematics. This is logic part 4. We are on the first topic, propositional logic and propositional equivalences. And as we talked in the previous lecture that we are going to see the truth tables for the compound statements, let us move further. Now the truth tables, facts are there. Let us see the few examples to understand it. How many rows appear in the truth table for each of these compound propositions? The first one, P implies negation P. Since there is just one propositional variable which is P, the truth table will contain how many rows? 2 raised to 1. So that will be 2 rows will be there only. The second is P or Q implies P and Q. Now since there are 2 propositional variables, the number of rows will be 2 raised to 2. That means 4. The third one is P and negation Q or R or negation S. So we have how many propositional variables? 4. So it is 2 raised to n means 2 raised to number of propositional variables, and therefore number of rows in the truth table will be 2 raised to 4, that is 16. Now let us see how we are going to construct the table. As we have already seen what will be the truth table for the negation, conjunction, disjunction, implication and by implication. We are going to use those facts only here, and we are going to write the truth table for the compound statements. Now let us construct a truth table for each of these compound propositions. The first one is P or Q implies P and Q. Now first of all, you should be able to understand that how many propositional variables are there. There are 2 variables P and Q, and therefore the first 2 columns will be, the first column will be for P and the second column will be for Q. So to have all the possibilities or all the combinations of the T and F, that means truth and false, so we are going to write the first column as TTFF and the second as TFTF. So this will give me all possible combinations, and therefore the next column will be the first compound statement, which is P or Q. The second compound statement is P and Q, and the last one is P or Q implies P and Q, since we want to construct the truth table for this statement. Now let us see the third column. We know that OR statement is false if both of them gives you the false value. So this is false, otherwise the statement is true. So it will give me TTTF. I know that P and Q statement is true only if P and Q, both of them are true. This will give me TFFF. Now the last column, P or Q implies P and Q. So we are talking about the third and the fourth column. Since it is implication, it is false only when the first column is false, the third column is false, true, and the fourth column is false. So it is false if TFTF, and therefore second and third row will be a false statement, otherwise it is true. So this will give me the truth table for the compound proposition. Now let us see the truth table for the next compound proposition. Now next we have P implies negation. In the bracket we have Q and R. So there are 3 propositional variables. That means the rows in the truth table will be 2 raised to 3, that is 8. So to have all possible combinations of truth and false for all of them, all these 3 statements, the first is 4 times T, 4 times F, then Q will be 2 times T, 2 times F, and R will be TF, TF, TF and TF. So we have all possible combinations, and let us go to the first statement. Since we have taken here P statement is already there in the column number 1, so we will see Q and R. Then step by step we'll go to the negation Q and R, and then P implication, negation Q and R. So again Q and R will be true only if the statement Q and the R. That means we are talking about the second and the third column only if that is true, otherwise it is false. So we get the fourth column. Negation of Q and R will be, it will be false when the statement is true, and it will be true if the statement is false. So we have other way, we have written the negation Q and R. Now the implication statement, P implies negation Q and R. That means we are talking about the first column and the fifth column. And we know that implication is false only when the first column will give you true and the next column will give you the false statement. So we have the last column as F and the rest of the entries are true. So this way, whenever this propositional compound statement doesn't have any truth value, only if we know the actual truth value, if we are given actual values, actual statements are assigned to these propositional variables. Since these are the variables, we have all possible combinations and we have the truth table, so we can decide whether it is true or false. So we can practice more of such examples in the next lecture. We are going to see the contrapositive and the other terms. Thank you.